Hey everyone, and welcome. Today we're going to tackle one of the most important ideas in all of math, polynomials. Now, I know they might sound a little intimidating, but trust me, they're just the fundamental building blocks for all of algebra. So, let's jump right in.
You might be surprised to hear this, but the answer to all of that, it's polynomials. They are the secret engine running behind the scenes of so much of our modern world. So let's pull back the curtain and see exactly how they work.
All right, so before we can start building with these things, we've got to learn the language, right? This first part is all about getting down the basic vocabulary that makes everything else possible.
And this quote right here, it really hits the nail on the head. At its core, algebra is just arithmetic with a cool new twist. We're using all the same rules you already know, add, subtract, multiply, divide, but now we're using letters to stand in for numbers. It just lets us work with quantities before we know their exact value.
And to make that happen, we've got two kinds of letters in our toolbox. First, you've got variables, usually your x, y, and z. Think of them as placeholders for a number that can change or that we don't know yet. Then you have constants, like a, b, and c, which stand for one specific fixed number. Getting this difference down is totally key.
Okay, so it's time to meet the absolute star of our show, the monomial. Seriously, if polynomials are some giant, complex Lego castle, the monomial is that single essential brick. Everything, and I mean everything, is built from this one little piece.
So here's the official definition. A monomial has two main parts. You've got the coefficient, which is a, that's just the number out front. And you've got the degree, which is k, that's the exponent. Now, here's the golden rule, the one thing you have to remember. That exponent k, it must be a non-negative integer. 0, 1, 2, 3, and so on. No fractions, no negatives. That's the key.
Let's look at some examples to make this super clear. For 6x squared, the coefficient is 6 and the degree is 2. Simple. For negative 5x, just remember that's the same as x to the power of 1, so the coefficient is negative 5 and the degree is 1. And get this, even a plain old number like 3 is a monomial. Why? Because we can think of it as 3 times x to the power of 0. Pretty cool, right? Okay, this is so important it gets its own slide. This is the non-negotiable rule. See 6x squared? The exponent is 2, a nice whole number. That's a monomial. But look at 3x 1/2. That exponent 1/2 is a fraction. That's not an integer, so it's not a monomial. Same goes for negative exponents. If it's not a whole, non-negative number, it breaks the rule. End of story. All right, so we've got our fundamental Lego brick, the monomial. What's next? Well, we start snapping them together to build something bigger. And that's where the polynomial comes in.
And would you believe it? This is the big secret. The whole thing. A polynomial is just a bunch of monomials added or subtracted from each other. That's it. It's that simple. It's just a chain of those building blocks we just mastered. Now, of course, we've got some special names for all the parts, just to make things easier to talk about. Each one of those monomial pieces is called a term. The degree of the entire polynomial is just the biggest degree you can find on any one term. And for a couple of shortcuts, if it has 2 terms, we call it a binomial. If it has 3, it's a trinomial.
Okay, so we know what they are. We know how they're built. Now for the fun part. What can we do with them? Let's dive into the basics, adding and subtracting these guys.
So one way to do it is what we call the horizontal method. All you're doing is looking for like terms, the ones that have the exact same variable and exponent, and then you just group them up. So we find the x cubed terms and combine them. Then we find the x squared terms and combine them. You go through term by term until you have your final simplified answer. But hey, if that feels a little messy to you, you can do it vertically. This is probably going to look super familiar, kind of like how you learned to add big numbers back in grade school. You just line up the like terms in their own columns and add straight down. See? You get the exact same answer. Seriously, there's no right or wrong way here. Just pick the one that makes the most sense to you.
All right, let's talk multiplication. Now, you could always multiply everything out the long way, term by term, but who has time for that? There are some awesome shortcuts, some special moves that will save you a ton of work. Think of them as algebra cheat codes. Let's check out these two big ones, the difference of squares and perfect squares. Look, instead of doing all that multiplying, you just plug into the formula. For example, with perfect squares, if you have x plus 7 squared, you just go x squared plus 2 times x times 7 plus 7 squared. Climb that up and bam, x squared plus 14x plus 49. So much faster.
Okay, deep breaths. We've handled addition, subtraction, and multiplication. Now it's time for the final boss, division. I know, it looks scary, but I promise you, the whole process is built on something you already know how to do, something you probably learned a long time ago.
Remember this? Good old-fashioned long division with numbers? The pattern is always the same, right? You divide, you multiply, you subtract, you bring down the next number, and then you do it all over again. That exact pattern, divide, multiply, subtract, repeat, is what we're about to use. If you keep this in your head, the next part's going to be a breeze.
All right, here we go. This is our problem. We're going to divide this bigger polynomial, the dividend, by the smaller one, the divisor. Let's get to it, using that same pattern we just talked about.
Okay, don't get overwhelmed. We're going to do this piece by piece. Step 1. Just look at the very first term of each piece. We divide 3x cubed by x squared. What's that give us? 3x. Easy enough. Step 2. Now we take that 3x and multiply it by our entire divisor, the x squared plus 1. That gets us 3x cubed plus 3x. Got it? And finally, step 3. We subtract that whole thing from our starting polynomial.
And now, we just do it all over again with the new polynomial we have left. It's the same exact process. Step 1. Divide the new leading terms. 4x squared divided by x squared is just 4. Step 2. Multiply that 4 by our divisor, x squared plus 1, which gives us 4x squared plus 4. And step 3. Subtract. Now look at what's left. The power of x is smaller than in our divisor. That's our signal. It means we're done.
And there you have it. That's our final answer. The main part, the quotient, is 3x plus 4, and what's left over? The remainder is negative 2x plus 3. We did it. We tackled polynomial long division.
So from that one single Lego brick, the monomial, all the way up to complex operations like long division, we've seen how these algebraic building blocks all fit together. And it's not just for math class. This is the language that's used to design roller coasters, to forecast the economy, to create amazing graphics in video games. So the real question isn't what polynomials are, it's now that you know the building blocks, what could you build with them?